models are very important in science. It lets us test ideas and show relationships between items. This is a pretty good model for the Earth and the Moon, although the distances are not right. But the Earth is about 4 times wider than the Moon. We're having an eclipse, and most people, when they show the eclipse, use a flashlight to show the sun. But the problem with that is, it makes the shadow of the Moon much larger than the Moon itself, and that's not what's happening. So I made a different sun. Now this is 16 small LED flashlights around the side of an embroidery hoop. It's still not the right scale for the sun, but it's large enough to show what I want to show. So with the larger diameter sun, it's going to be able to make the shadow of the Moon smaller onto the surface of the Earth. Now as having our eclipse, the Moon will be moving in its orbit, and so the shadow of the Moon will be moving across the Earth. So only if you're in the area where it is totally dark, that's called the umbra, that's where the total eclipse will be. All of the rest of the partially shaded area, that's going to be what we call the penumbra. Grand Prairie will be in the penumbra. At maximum, we'll have about 75% of our sun covered up by the Moon. Now, the sun's orbit, or the Earth's orbit around the sun, and the Moon's orbit around the Earth are not perfectly circular. Sometimes the Earth is a little bit closer to the sun. Sometimes the Moon is a little farther away. If that happens, then the size of the sun in the sky will appear slightly larger than the size of the Moon, and so the shadow of the Moon would get smaller and smaller and smaller until finally it's not visible, no totality at all. There would be a ring of fire if you saw that. That's called an annular eclipse. But what we're having is a total eclipse if you're along the pathway where totality occurs. In Grand Prairie, you will be in the penumbra.